Hello everybody, welcome to a new episode of AZ Security. My name is Dinan Paardenkoper. I'm a cloud security architect at IT Impressive. And today I have a special guest, and that's Rex.
Hey, I'm Rex de Koning, Azure Networking MVP, senior cloud engineer at a Microsoft service provider in the Netherlands called InSpark. And I do some things with Azure Networking.
And that's great because that is the topic for today. It's all about Azure Networking. What do you have in store for us, Rex?
Yeah, so I prepared a little bit, also looking at the name of the podcast, of course, AC Security.
Obvious.
So I decided to go back to call it AC Security 101. We're going to look at basically the basics of Azure Networking, so some vNets, what are the options with a vNet, and how can we secure them a bit more to make traffic not go everywhere, but only via the routes that you want them to go. But yeah, it's important to go back to the basics because that's where you build up from. So
Yeah.
Let me see if I can share my screen. So that's a good start. So what I've done, I've created a couple of demos. So the slides are very simple. So basically what we have here is, let's call it network diagram for my first demo. And what you see here is that we have two vNets. So we have one with a CIDR range or a network range of 10.0.0.0/23 and one with 10.0.2/0/23. In there we have a subnet, and within that subnet we have a network interface card and a virtual machine. So the network interface card is connected to the VM, the NIC to the subnet, and the subnet to the vNet. And in that other vNet we have the same. And as you can see, these are two separate vNets. So they have no connection with each other. Let me go here. And if we look in Azure, so we have our vNet. Here we can see the address range. We have our subnet, just like mentioned in the diagram. And as you can see here, we have no security group and no root table. So it's just one totally isolated thing. So now if we go to the virtual machines, and we log in there, and I will also do that for my other VM in the other network. And as we can see here, where is my IP address? This one is in the 10.0.0.10.0.2 range, and the other one is in the 10.0.0 range. So if we log into this one, all right, so we have VM1, and as we can see here, we have our IP address 10.0.0.4, and on VM2 we have 10.0.2.4. So if I now say a ping to 10.0.2.4, or on this side a ping to
Right.
then we will see that nothing happens, which is expected in this case because these are two separate networks that have no connection with each other and therefore cannot reach each other. So if I stop this one, we can see that, well, 100% packet loss. And on the other side, we have exactly the same. But yeah, in a network, sometimes you want to reach other machines. Makes sense if you build up something. So if we're going back to this part, so we have these virtual networks which are separate, and then there is a thing called network peering. And basically, what you do with network peering is turn these two networks into one big network. So if we look at the image, we basically get one big vNet with two IP ranges, with two subnets in this case. We have the same subnets, so the same IP addresses. But since these are in the same virtual network, they should be able to reach each other. So if we go back to Azure, then I have to go to another resource group. So we have our vNet and the same vNet. So we have the 10.0.0.0/23. We've got one default subnet, the same as the other one. But the thing that is different here is that we have a pairing, which basically means we connect vNet 1 to vNet 2 to make it one big virtual network. So if we now go to the virtual machines, that's the first, and then the second. And then again, we can see here that this machine has 10.0.0.4/24. The same goes for VM2. That has 10.0.2.4 as an IP address. So if we say now I want to do a ping to 10.0.0.4, we will see that it replies. And on the same from this machine, if we do a ping to 10.0.2.4,
Nice.
we will also get a reply. And to make it more interesting, in this case, I also have a third virtual machine, which has this IP address, 10.0.0.5. So if I do here a ping on 10.0.5, it will just reply. The same from this machine, because they're all in the same happy network. And this will just work. But if we go back to the network, and to the subnet, we will still see there is no security group here. And a security group, say it's very simple, is well, most people have heard of a firewall. And a security group just means that you put some firewall rules basically upon a virtual network so that it behaves in a certain way. So in this case, I'll attach my network security group. And as you can see, it doesn't do a lot, but it disallows ICMP, so the ping that we are doing, to this specific IP address. So now if I go back to my machines, you will see that this isn't scrolling anymore. So when I stop this, you will see that it has stopped getting responses. So if I start it again, nothing will happen. And the same for VM2. It also started dropping packages. So if I start it again, nothing happens. And this is basically something that you always want to set up on your virtual network, especially if you go some deeper into networking, you start to work with hub-spoke models, for example. And with hub-spoke, you're going to pair a lot of networks together. And if you don't use network security groups, basically it becomes one big network where everybody can talk to everybody. And yeah, that's usually not something that you want. So even within one because it is one environment, you still want to block off different services so that not everybody can access your SQL database, can access your key vault, can access some storage account. And that's why the network security groups are so important. A lot of people think, well, if I send all my traffic towards a firewall, I'm okay. Usually it is okay, but yeah, so some minor misconfiguration and everything is open again. So always make sure you have your network security groups in place. And then since March 31st of this year, Microsoft also changed some other network settings. And if we go back to our subnet, so I've created my vNets with the subnets in two different ways. This is the new default. So enable private subnet, no default outbound access. So when you create a new subnet, this is the default. And if we look at vNet 2, and then our subnet, you will see that it's disabled here. And well, what is the big difference between these two? So for example, if I'm now gonna request a website, let me see, IP, sorry, IP info.ip. As you can see here, this one just keeps on trying, nothing happens. And if I do this from this machine in vNet 2, then I will get a reply, and in this case it's some website that just shows your IP info. So this is now the IP address that I'm using to access the outside world, that's vNet. This is from the subnet without the private networking enabled. And on this VM where it is enabled, which is the new default, you can see it's still trying to go outside, but nothing happens. And of course, you might want your VM in this case to reach the outside world. So there are different things that you can do in this case. One thing that you can do, but what you don't want to do because of multiple security issues, is give the VM a public IP address. That's almost never a good idea. So what you would do, there are basically some other options, of course. One thing that you can do is deploy a firewall, route all the traffic from the VM towards the firewall, and go to the outside world via the firewall. For this demo, I set up something else. So if I now go back to my vNet 1, I go to my subnet, and in this case we're going to use a so-called NAT Gateway. And a NAT Gateway is basically a very simple device that you can connect to a subnet, and then it will route by default all traffic from that subnet via the NAT Gateway towards the internet. So if I save this one, and if we're going to look at the NAT Gateway, we're using this one. So we can see it's connected now to one subnet. So it's my vNet 1 and then the subnet default. And another thing that we have here is a public IP address. And it is this one, NAT Gateway 1. So 20.86.132.174. So now hopefully, if I run this command again, it will do something on my VM1. And now we will see that it uses this IP address to connect to the outside world, so that all traffic from this machine is now running via the NAT Gateway, so it can reach the internet to get whatever you need. And another great advantage of using it like this, when I do this here, theoretically, I will now probably every time get the same IP address, but this can rotate. So if I turn the machine off now, for example, and turn it on again, it will probably get a different address where it connects from. But of course, a lot of services at third parties also always use IP whitelisting, so that not everybody can connect. So by using it like this, by using a NAT gateway or a firewall, you make sure your traffic always comes from a fixed IP address, which also makes it easier to whitelist.
I agree. And if I look to the NAT Gateway, that is a PaaS offering, right, from Microsoft? And does it also
It's
have
a PaaS
protection
offering,
enabled,
yes.
like Azure D does?
So you cannot enable it, NAT Gateway itself, but you can enable DDoS protection on your vNet if you want. And there is some basic DDoS protection already in place on every vNet. And if you want and have a very big credit card, you can also enable the extended version.
Yeah, true.
By default, the NAT gateway does nothing. There's also another, for example, in front door or an application gateway, you have the web application firewall. That's also not included in the NAT gateway. So this is really just pass it on as it comes in. So there's nothing in between. And if you, of course, route your traffic via the firewall, you can do some inspection, put some firewall rules in place. But yeah, the NAT gateway is basically a stupid thing. Just what comes in goes out. And of course, from your VM, you can also, if you're in a hub-spoke model, there are different things that you can do. For example, if your firewall has multiple external IP addresses, it will rotate those addresses for the outgoing traffic. So then it will still choose one of those addresses, so you never know which address it's going to use. So if you have a third party that always relies on one IP address, then it still makes sense to put a NAT gateway in between the VM and the internet. But then just create a route table on your vNet for that subnet where the VM is in, where you basically say, well, I'm going to route all my traffic towards my firewall, except traffic towards this specific IP address or IP addresses of that third party. They will go via the NAT gateway. So yeah, this is the thing that we just shown, and I see I made a typo. This should be a 5. So this is the machine that we were trying to get, which doesn't work because of the NSG. And here we have the demo that we just seen with the NAT gateway in between. So yeah, that's very simple, the networking 101. And of course, there is a lot more that you can do with Azure Networking. We were talking before a little bit, and one of the things you mentioned was maybe it's interesting to show some vNet injection. And since we're here, why not? So vNet injection, for people who don't know what that is, that's basically, for example, if you have a function app, because that's something that I have up and running, so I can show it easily. A function app or a web application, basically, if you look at them, so here I have a function app, and people who deployed function apps or web applications within Azure will probably know. So networking. I already did the injection here, but it doesn't matter for the demo, for the story. So basically, when I go to my web app, in this case my function app, and in this function app I basically call the same URL that I have here. And then I will always get one of this, I think it's about 25 addresses, and you never know which one you're gonna get. And that's not always something that you want, also because of security towards third parties. If they have a database running or whatever you want, they're not gonna allow all traffic. So what you can do is set up virtual network integration. And what you do there is basically you connect your function app to a subnet, so in this case subnet function out. And as you can see here, I have also connected to that subnet a NAT gateway. And if we look at that NAT gateway, we will see that it has this IP address, 20.31.36.202, if I do it right. Where is it? Get function URL. So now we're doing a call to my function app. It has to start up, so it takes a bit longer this first time. And basically what it does, it gets out some data, and then it will show you my client IP, so the IP address of this function app, and the server IP. And the server IP is, as we can see here, basically the same call to the ipinfo.io website. So here it is now. So now we can see here that we have 20, 31, 36, 202. And if I'm not mistaken, that was my
It is.
gateway. So that's working. And as you can see here, we have a public IP address for the client IP. So if I go to my function app again, networking, then we can see that it is. Let me check it just to be sure. That's not the same one. That's weird. Oh, yeah. No, I was totally thinking in the wrong way. Of course, this client IP, since we're on this network, if we scroll up a bit, we can still see it here. We're coming via the NAT Gateway on this vNet.
Not a problem.
I totally forgot about that one. So that's why that's my client IP. Sorry for that. And then we have another nice one. If I check this website, well, it isn't as beautiful in here, but you can get the gist of it. We're not allowed to access this website. And that is because, let me go to that site. If we go to networking here, then you can see public access is disabled, so we cannot reach this website. In this case, we also have vNet integration for the outgoing network of traffic, but we also have some private endpoints. And private endpoints in this case are used for the traffic into the function app. And basically, a private endpoint is just an extra network card connected to this function app, which is connected, I'm gonna use this one, to a specific network basically. So we can see here, it's connected to this network. So that's within my own network. And because public access is closed, that's why I cannot open the website.
Making it more secure.
But yeah, but we have a problem because you might want to reach that website in some way. So for example, what you can do, and I need to open this one to copy the URL, is for example, you can use a front door. And in this case, I use the front door premium because then I can connect directly towards the private endpoints. So if I now copy this URL and I put this, I think it was trigger one, API/trigger one, yeah. So basically what I'm doing now is calling the same website only via the front door. And as you can see here, because I just opened this up in my local browser, in this case, this is my local machine. Then I go to the front door. And then I go via the private endpoint. So this is a private IP address. I go towards my function app. And in this case, we see an address 9.163 something. And if I am not mistaken, that should be my firewall in this case. Public IP. Yeah, so my traffic here is routed towards my firewall and from the firewall to the internet. But if you're working with this, there's also some other things that you can do. For example, we can use API management. Yes. So what I've done, I've created an API management service. I've got an operation called get IP. And when I'm going to test that one, it will basically make this call. I'll just put it in the browser, that's easier to see. And now we have the same entrance to the same function app, which is closed for public access. And as you can see, we come in from my public IP address. And in this case, the API management without an external address routes it directly towards the function app via a private endpoint. And again, we have the same public IP address for the outgoing traffic from the function app towards the network.
So basically you have hardened your function app.
Yeah, we've hardened the function app, so we only allow traffic that we want. We also make sure that the function app itself cannot reach everything on the internet, only the sites that we want to. It's not reachable from the outside world. It's of course usable within Azure. We made it available in this case via API management and front door. I could also start up a VPN connection and then I can access it. But yeah, if you massively reduced your attack surface now. And basically because your front end now comes either via front door or API management from the outside world. There's just one port that is open, that there are no different endpoints, which makes it a lot more secure. And you can steer the traffic in ways that you want. And another thing, it's now easy to see in your firewall the traffic that comes in and the traffic that comes out, so that you can monitor that too.
I really like that solution.
Yeah, it's a nice and simple way, but I found that not everybody knew about these ways. And it's really so simple, basically. So if we go to my function app in this case, it's really just closing this one, setting up your private endpoint. And for the outbound traffic, you got to make sure that you use virtual network integration. As you can see, we use no NAT Gateway in this case, but we do have a route table. And that route table just says all my traffic, so 000/0, send it towards my firewall. So now all the outgoing traffic is just going towards my firewall. And if we look in the firewall, I have it's not a security best practice, but I have one rule in there. So in this case, what I've done, I've also called it do not use in production. Basically, I just allow everything because it's just for a demo and I will throw it away anyway. And I think I've set up, I have to go back to the firewall. I think I've set up my diagnostic settings. Oh, no, I did. I have the diagnostics firewall. Oh, I didn't allow. Well, I can't show it now because I have the wrong rules. Because I only have a network rule which is unlocked at this moment. Because otherwise I could show you that the traffic is really going towards the firewall. And one other thing I always think is funny to show. If we go to the networking tab again, you might have seen that we have two private endpoints. This is the one that I created and is used, for example, by API management. If you create a private endpoint, a private endpoint connection via Azure Front Door Premium, which is a PaaS service, it will also create a private endpoint that is managed by Microsoft. So if I click on my own private endpoint here, the one that I created, I see all the information. I can see what the FQDNs are, what the IP address is. But if I click on this one, I don't have access. And that's because it's a Microsoft managed one. So this one lives basically in the Microsoft tenant itself because it's a PaaS service. And that's something to keep in mind. That if something like this happens on a resource which you think you have, then it's probably because it's a managed resource.
It's a familiar one. If you use specific limitations that you can block resource creation, then you also get an error message like, hey, I can't create the private endpoint.
Yeah, and you see it also when you work with, I think it was with Databricks, for example. which create a managed vNet. So then you have a vNet and things in it, but you cannot do anything with it. If you use it PaaS services, that is something to keep in mind, that even though you see resources, you might not be able to work with.
If I recap our session, what is one liner that you want to give back to the viewers?
Always start with thinking about security. I mean, especially in Azure or one of the other cloud providers, it's so easy to set up your resources. I can do a couple of clicks and I have a virtual network. I can connect to the internet. I can do everything I want. And with a click of a couple of more buttons, I have a second vNet, which we've shown with some resources in it. And as you start pairing them up, you got to keep in mind that it becomes one big network and everything can talk to each other. So don't forget your network security groups, even though it seems like overkill. It was a bit more than one line, but yeah.
No problem, no problem.
Important.
Rex, I want to thank you very much for your explanation, also for your demonstrations. I think this gives a lot of people who are new to this topic great ways to start. Any last thoughts?
Well, awesome being here and
Likewise.
Good to see you again. Perhaps we can do it again with a more into depth.
I'd love to. Any great topics to share, please let me know and then I will introduce you back.
I will.
For everybody at home, I want to thank you very much for listening, for watching. If you have any things or thoughts, please leave them in the comments below. And otherwise, I would say take care until next time.
Thank you very much and have a good day.